Previously, I talked about the different types of 3D printers you can buy and some accessories I recommend picking up. Now, let's turn our attention to actually printing something. I'll show you how to level your bed, change your filament, configure your slicer, and how to print your first part. After this, you should be ready to start using your 3D printer. If you'd like to design your own parts, come back for my Introduction to FreeCAD series, but let's jump into the actual printing part. Before we start, I'd like to make a note about materials. Simplify 3D has a great overview of popular FDM materials that I'd recommend checking out. Some are stronger than others or offer more heat resistance. The important thing is to make sure that your printer actually works with the material you want to work with. The guide for your printer should list the approved filament types that you can use. In this video, I'll use PLA. It's fairly strong, but can be somewhat brittle. It also doesn't have much resistance to heat. That being said, I recommend starting with it as it is inexpensive and relatively easy to print with. Most printers can handle it without a problem. When you first get your printer, you'll want to follow the manufacturer's instructions for setting it up. Every machine is different in this regard. Be prepared to spend a few hours on this part. Before you print something, I highly recommend learning the controls of your printer. Most will come with some kind of control panel. There are likely a lot of settings, so I'll just show you the main ones you need to worry about. The first thing to figure out is how to control the printhead, bed, and extruder. When you turn on your printer, the printhead and bed should automatically find their home positions. If you accidentally bump something or cause one of the motors to skip, I recommend selecting either auto home or homing the individual axes. For example, if I select home Y, the bed should move to a predefined location. In most cases, the stepper motor will just move the printhead, gantry, or bed until it hits a limit switch or sensor, which lets the printer know that the mechanism has reached its home position. In other words, we are zeroing the axis so that it starts in a known location. Next, you should understand how to move the individual axes. Find the movement function, select the axis you want, and in my case, I have to select coarse or fine movements. From here, I can manually move the mechanism by rotating the dial. Your printer might be different. As I'm moving the x-axis, that is causing the printhead to move along the gantry, left or right. Knowing how to move the different parts around is crucial if you need to access a part or perform maintenance. Next, let's talk about bed leveling. Newer printers often come with auto leveling mechanisms, but you still need to set the Z offset for that to work. Some printers have 4 knobs under the bed, 1 in each corner. If you see this, then you'll need to manually level the bed. Use the control panel to set the Z-axis to 0. Slide a piece of paper under the nozzle and turn the knobs to raise the bed until you feel a slight amount of friction on the paper from the nozzle. You'll then want to repeat the process for all 4 corners. If you have a printer that auto-levels before each print, like my LulzBot, you'll still need to adjust the Z offset so that the printhead has a known good starting point before taking measurements. Some printers have a Z offset wizard, but I'll show you how to do it the manual way. First, move the X and Y axes so that the nozzle is about in the middle of the bed. Home the Z axis or set it to 0. Then find the Z offset setting. This will allow you to make tiny adjustments to the printhead, which will then be stored as the new 0 point for the Z axis. You can turn the knob to raise or lower the gantry to set the Z offset. Place a piece of paper under the nozzle and turn the knob until you feel a slight amount of resistance on the paper while moving it around. Exit the adjustment screen. On some printers, like this one, you'll need to manually save the settings so that they take effect. You'll want to level the bed or calibrate the Z offset the first time you set up your printer and after moving your printer to a new location. Other than that, you should only need to do it maybe once or twice a year or if you start having first layer problems. The other important thing to know is how to change the filament. Each printer is a little different, but I'll show you the basic procedure on mine. The first thing you want to do is preheat the hot end to the temperature required by the filament that's currently in the printhead, or the filament you want to change to, whichever is hotter. You should have an info page that tells you the current and target temperatures of the nozzle and bed, assuming you have a heated bed. Wait a while, and after the nozzle reaches the target temperature, you can navigate to the extruder control screen. This allows you to extrude or retract the filament. One direction pushes the filament through the hot end, which causes it to melt and come out the nozzle. The other direction pulls the filament away from the nozzle. The official method involves using the control panel to retract the filament until it pulls free from the print head, but some printers have a tension or release lever that you can pull to release the filament from the drive gear and idler wheel. I will often just pull this lever and pull the filament out manually once the nozzle is up to temperature. If you're putting in the same type of material, you can just leave the temperature alone. But if you're switching to a different material, you'll want to preheat the hot end to the temperature required for that filament. Sometimes the filament end balls up from melting, so I will often cut off a centimeter or two so that it feeds into the print head more easily. Once the nozzle reaches the correct temperature, replace the filament spool on the holder. Some printers have a runout sensor that will pause the print if the filament runs out, allowing you to switch to a new spool on the same print. Make sure to feed the filament through that first, if you have one. Then feed the filament through the guide tube if needed. Put the filament into the print head. Use the control panel to run the extruder motor. While attempting to extrude, carefully move the filament around until the drive gear catches it. Keep extruding it until you see it start to ooze out of the nozzle. If you're moving to a lighter color filament, you'll often have to extrude for a while to get the color to fully change. If you're lazy like me, you can also pull the tension lever and manually feed the filament into the print head. This allows you to extrude filament faster to get the color to change. Now that you understand how to remove and add filament, let's try our first print. Some printers offer network-based portals that allow you to control the printer or send jobs. Or you can install Octoprint on a Raspberry Pi to accomplish the same thing. But I'll show you how to use a good old-fashioned SD card, as most printers still support them. Plug the SD card into your computer and follow the manufacturer's guidance on how to format it if it doesn't come formatted from the factory. In 2015, Creative Tools released this cute toy tugboat model as a benchmark test print. The curves and overhangs make it tricky to print. As a result, they called it 3D Benchy, or just Benchy, and it's believed to be the world's most 3D printed object. You can find it on nearly every 3D model sharing site. Let's head to printables.com, which is one of the more popular model sharing sites run by Prusa. Search for Benchy and then sort by most popular. Click on the 3D Benchy page. In many of these sharing sites, you can view photos uploaded by the user as well as examine a 3D model. Open the 3D viewer and you can click and drag the model around. Close the viewer and click the download button. Click all model files to get the STL file. Feel free to sign up for a Prusa account, but we can just ignore the pop-up for now. Unzip the downloaded file. You might get other files, but what we care about is the STL model file. This originally stood for stereolithography, but it's now a very popular file format for just about any 3D printing method. Before we print, we need to convert this model to a set of instructions that the printer understands. A slicer is a program that helps us do that conversion. It takes in a 3D model, often an STL or wavefront OBJ file. You can then adjust a number of settings to control the actual printing process. This includes things like bed and nozzle temperatures, print speed, line and layer widths, bed size, internal structure known as infill, and how to generate any required supporting structure. The slicer uses this information to construct a tool path, which is how the print head will move to physically create the part. This path is then exported as a set of instructions that can be read by the printer. Most printers accept G-code, so most slicers will export toolpaths in G-code format. Open your slicer program. Most manufacturers will recommend a slicer that works best with their printers. In my case, I'm using the LulzBot edition of Cura. Your slicer might be different, but the same concepts apply. You'll want to select your printer's profile, as that contains information about the print head, control scheme, and bed size. Add the profile if it did not come with your program. You can likely find profiles on the manufacturer's site. From there, select your material. I'll be using PLA for this demonstration. Just make sure that the material you select here is the same material you loaded into your printer. You might have different material profiles. I recommend going with high detail to start so you can see what your printer is capable of. Feel free to switch to high-speed profiles later. The settings can be overwhelming at first, so I'll go through a few of the main ones that have the most effect on the print in a minute. For now, click Open and find your Benchy STL file. When you open it, the model should appear on the virtual print bed. With Cura, you can move the camera around by holding the right mouse button, and you can pan it by holding the middle mouse button. You can also zoom with the mouse wheel. If you move the camera under the bed, you should see the bottom face highlighted in blue, which means that it's touching the bed. Parts in red indicate overhangs, which will be tough for most 3D printers without creating some kind of support structure. Benchy isn't too bad though. You can click on the part, which will enable the Modifications tab on the left. With this, I can move the part around, rotate it, scale it, and make copies. I'll leave them at their defaults. Click Slice. After a moment, the model should show the actual printed layers. You can use the slider on the right to see how each layer will look during the printing process. Let's take a moment to talk through some of the important settings. The Quality category in Cura contains settings that affect the layer height and line width. The diameter of your nozzle often determines these, but can be adjusted some. Generally, wider lines and taller layers mean faster prints with reduced resolution. I prefer more resolution as I don't mind waiting for my prints. Wall thickness tells the slicer how many lines should be placed for each wall before doing infill. This only affects the horizontal XY plane. If we drag the layer slider down to see the inside of the hull, you can see this in action. In most cases, parts are not solid plastic unless you explicitly make them so, but this often wastes a lot of material. The internal structure is often a simple crosshatch, which is known as infill. The walls surround the infill to make the part look solid. If we change the wall thickness to 3 mm, you can see that the line count is automatically updated. Slice again, and the walls of the hull are now much thicker. Change the wall thickness back to 1 mm. The top-bottom thickness settings control the wall thickness in the vertical Z-axis. It affects how many layers are 100% dense walls above and below the infill. You can change the infill density and pattern. Try different options here. Some patterns might work better for your particular design. I'll leave the density at 20% and the default grid pattern. What Cura calls material is really the temperature control. Here you can change the target temperatures of the bed and nozzle during printing. Sometimes you'll want different temperatures for the first layer and final layers. This is often determined by your material and might require some tweaking. I recommend starting with the default and running a few tests to find a good temperature for each new material. Speed is, well, how fast the printhead moves during printing. Once again, this is often determined by the flow rate properties of the material you're working with. Higher speeds usually mean faster print times, but you start running the risk of having errors in your print. Retraction is the amount the filament is pulled back into the printhead whenever it moves to a different section of the print that isn't connected. It can help prevent oozing and stringing. The distance and speed often require a little tweaking as every material is different. Many printheads have a fan on them that blows air on the part to help the plastic cool just after extrusion. In most cases, you want the fan on to help the material set. However, some materials, like ABS, require little or no cooling, as the whole part should stay warm until the print is done to prevent warping or cracking. You'll also sometimes see the fan disabled for the first layer to help the material stick to the bed. Once again, this is something to tweak if you see warping or having issues with first layer adhesion. Support is extra material placed to help prop up overhangs. It's essentially scaffolding. Our boat has some overhangs, mostly in the cabin. To see how support material works, let's turn it on. Just like with infill, you can adjust the pattern and density of the support. You can also specify the minimum angle in which the slicer will add support material. Most FDM printers can handle about 45-degree overhangs without much of a problem. More than that, and you'll start to see the material drooping. 60 degrees is a good compromise, so let's go with that. Leave everything as default and slice again. That's a lot of support material, which will require us to manually remove a bunch of material. Not only is this wasteful, but it also leaves bumps and marks on the print. Since the overhangs are relatively small, most modern printers can handle Benchy without much of a problem, so let's disable support for now. Printers that work with multiple materials will let you print the support in a different material. You can buy water-soluble filament so that you just need to wash your print to remove the support structures. If you look below the boat, you can see a few lines that surround it. This is known as a skirt. In many cases, the filament will ooze or not stick to the bed in the first few centimeters of motion during a print. The skirt ensures that the filament is flowing before starting the actual print. You also have the option of printing a brim. This is like a skirt, but is attached to the base of the print object. You'll need to peel it away when the print is done, but it helps make sure that the first layer sticks to the bed. Try a brim if you're having problems with first layer adhesion. Then we have the Raft. This raises the part a few layers and prints a flat bed under it. It can also help with first layer adhesion and can help compensate for non-level beds. The part usually floats a layer or two above the raft, but it can still be difficult to remove the raft. I recommend using the raft only as a last resort if you're having issues with the first layer. You can also choose to print with none of the options, but I recommend at least a skirt. My printer doesn't have two extruders, but if yours did, you'd be able to set them up here. Special modes and experimental are new or esoteric features in Cura. Your slicer probably has similar settings. These include things like defining the print sequence for multiple parts, creating a mold for casting, and fuzzy skin, which is all the rage these days. This creates a rough texture on the outer wall, which can hide imperfections and create a unique look. I'll keep it off for now. Note that I just scratched the surface of all the possible settings. As you get more comfortable with your printer and your slicer, you'll probably find yourself digging into some of these more advanced settings. For now, let's keep the defaults. You can always change them and try again. Once slicing is done, Cura will sometimes automatically detect the SD card and ask you to save it there. Otherwise, you can save it to your hard drive and then copy the G-code file over to the SD card. Feel free to open the G-code file. G-code is a language used to control CNC tools developed in the 1960s. It's basically a list of commands where to move the tool head, or the print head in our case. The printer reads these and converts them to stepper motor movements to make the print happen. Copy the file to the SD card if you haven't done so already. Unmount the card and then remove it from your computer. I like to make sure the print bed is clean by wiping it down with some rubbing alcohol. If you're having problems with the first layer not sticking, you can also apply some adhesive here, like a glue stick. Insert the SD card into the printer. On the control panel, find the print from the SD card option and choose the G-code file. The printer will then preheat the hot end and bed. Some printers, like this one, will perform the auto-level process where it takes height measurements across the entire bed. It uses that information to calibrate the printing process. After that, the printer will start laying down some molten plastic. I like to keep an eye on it, at least during the first layer, to make sure everything looks okay. From there, let it do its thing. With any luck, you'll get a nice toy boat. Taller parts will simply let you grab them to remove them from the bed. Some printers have flexible beds that you can bend to help separate the part. In other cases, you'll need to use a thin metal spatula to get the part off the bed. 3D printers aren't perfect, so you'll likely end up with layer lines and a seam along the Z-axis. This is where the print head starts and ends its movement during that layer. Some gap filling and sanding are possible if you want to make it really smooth. Keep an eye out for any glaring defects like warping, large gaps, blobs, and stringing. Simplify 3D and All 3DP have great troubleshooting guides with photos showing you what to look for. I highly recommend starting here if you notice problems in your prints. I also recommend printing a few calibration parts and spending some time getting to know your slicer and printer. Benchy is a good start, but it's more of a generic stress test. A temperature tower has the printer change its nozzle temperature for each section, which can help you find the ideal printing temperature for that material. Stringing tests are usually two small towers that help you see how badly the material oozes whenever the print head moves. You'll want to play with temperature and retraction settings to minimize stringing. Simple squares that consist of just a few layers can help you identify issues with first layer adhesion. Finally, the calibration cube can be measured to help you figure out if your printer is making relatively accurate objects. It can also help you identify issues with printing along a particular axis. For example, shifted layers help me identify a problem with the set screws on my Y-axis stepper motor. I hope that these episodes have helped you get started using your 3D printer. There's still a lot more to learn, especially when it comes to working with different types of material. I'm still experimenting with this. If you want to take your skills to the next level, I recommend learning how to model your own parts using a CAD program. In my next video series, I'll show you how to use FreeCAD to create everything from simple brackets to propellers. I found that learning to CAD made me appreciate my 3D printer even more. So make sure to come back for that series. Good luck and happy hacking!